Hello and welcome everyone. In this video we're introducing a new Bricscat feature that solves a very specific engineering architecture and surveying problem. With the help of the point cloud profile sweep, we are able to identify repeated patterns of profiles and geometry along a path, and with the help of AI algorithms we can create break lines, polylines, profile lines, and surfaces along a specific path. Let's find out how it works. So I'm quickly switching in Bricscat. I'm introducing a point cloud capture that represents an intersection, a road, and pavements. In this particular project, we would like to compare the as-built model to the reality capture. So it's a critical task of the surveying professionals to create the break lines that represent the pavements. So in this particular case, what we can do is activate the profile sweep and zoom right in. And first things first, we will need to find an area of interest by clicking once, and then with a second click, we can define the direction. This tool creates a sectioning entity. We can see the result on the left side. And in this case, we're slicing through the point cloud by using this tool. There are a couple of options over here. We can make it a little bit bigger or smaller. I recommend making it as small as possible because this will increase the resolution of the points in the preview box. So let's make it as small as possible. We can also reduce the depth, but it's a good idea to leave a healthy depth of 10 to 20 centimeters so that the visualization of the points is includes a healthy amount of points. We can change the direction of this tool, but we highly recommend being as accurate as possible with the direction. And of course, we can always use those arrow box, the direction arrows to move the sectioning entity along a certain local axis. And now, about the next step, all we need to do is go inside this preview box and click on it once, twice, thrice, and so on. So what Bricscat does, it creates a polyline around those points. The vertices can be controlled individually, and after placing them into the correct location, we have a couple of options. First things first, Bricscat will create a geometry, in this case, either lines or polylines or surfaces. So for this step, let's create a polyline. The output can be either the profile itself or the key point lines along the path, but let's keep it at both at this point. And according to a certain accuracy percentage, the next steps will try to match this geometry along a path. So let's see how that looks. I will select this option so that the camera aligns with the movement, and I will immediately fire up the multi-steps tool. Now Bricscat runs along the path and creates geometry and stops wherever he thinks that the accuracy falls below the threshold we set. So at this stage, the next point falls under the 80% of accuracy. So what we need to do is go into the manual step, go into the next step, and check the status. So clearly we need to change something, and once we verify the manual step, okay, let's do one more step. Change the geometry to be a little bit more accurate. Then we can go back into the multi-steps and let it follow the path until it stops again whenever the accuracy falls below. So we can then pause this procedure, and we can always go back into the steps. So by clicking those arrow keys, I can cycle through each and every step that he makes. Take a note, he takes the step size into consideration. So in this case, we're doing 1.2 meter steps along the path. and let's see what the result looks like. Okay, so we could have reduced the step size to be a bit more accurate, but the direct result of this tool is the fact that we can create polylines that output either the profiles themselves or the step lines. So this actually gives us the outline, the polyline outline of the pavement. And by enabling the geometry surfaces, we can directly create a thin surface out of them. So going back into the steps, we can always go back in time and control how each individual step looks like. So if we're not satisfied with the geometry of a step, we can go back, move it around, change it, and automatically, as we can see on the modeling side, the geometry changes dynamically. So even if I make an extreme change, we can see that the result deviates significantly from the previously defined geometry. Okay, let's leave it at polylines, keep both, and after hitting apply, we can see the result clearly. Okay, let's enable the structure browser and hide the point cloud. Right click to hide the point cloud, and we have 63 polylines in the drawing that represent the break lines and the profile lines of the pavement. So this would be one of the workflows in the surveying industry. Now, what happens in the architecture and capture of an existing building or existing profiles? In this particular case, we have a wooden attic. We used Leica scanners to capture this floor, and we can clearly see an abundance of profiles. And as we zoom right in, we can understand that those profiles have some sort of deformation. So we can clearly see the wooden profile not having a perfect geometry. So let's see how we can model this together. Again, profile sweep solves this issue. I like to click on this edge right here and then create a second target point along this path. I can then, well, we can use it as we saw before to center this in a better way, make it smaller or bigger, and make sure that we get the best accuracy possible. So we will follow the same process. We will just click on the points, 1, 2, 3, 4. But in this case, we have a magic button over here on the top side, which connects the first and the last point by creating an enclosed polyline. So that means the profile is closed, but at any point we can just click and create additional points, which we can then use to follow the profile in a better way. And with the right click, we remove those points. So let's define this as best as possible. Raise the accuracy to 90% and define the step size to 10 centimeters. I want polylines and I want, okay, let's keep both at this point and just follow the multi-steps and see where we land. Okay, it goes all the way up. And in this case, I would like to go back a little bit and see what the result looks like. Okay, looks good. I can go at any point in my structure browser and hide the point cloud so I can see the formation a bit clearer. Okay. At this point, we recommend enabling each individual step, like going back on each step, just to make sure you're creating the profile in the best way possible. So let's repeat the process once again, a little bit higher. There you go. Repeating the process. because I closed it by accident. And here you go. Let's follow this path every 10 centimeters with an accuracy of 90. Let's do the multi-steps again, and then just go back a couple of steps and verify how the profile looks like. Okay, over here we can clearly see that we're a little bit off. So we can change that, move it into the best placement possible, go back into the other steps. Over here, we can go as much in detail as possible. So it's up to us to decide what do we actually need to model. I can click right here and create extra points. Same thing happens with that one. Whoop. And we can go in and just decide what kind of break do we need to create to be as accurate as possible. Okay. There you go. And going back steps, we can repeat this process as many times as possible in order to get the most accurate result. In the end of the day, we accept the changes. I want polylines, but in this case, I would like some step line. No, I would like to have the key point lines that clearly outline the geometry of the column. So I can go in, I can select them, isolate them, and now I can use these profiles to either manually loft each one individually, or just use a quick Lisp routine that I've created, loft sections, that automatically selects everything and creates a profile for me. There you go. So you can see the deformed geometry followed the most logical path you could find. And after enabling the point cloud, we can see that the deformation is as close to reality as possible. And now we can, of course, use this 3D solid to convert it into a BIM column, apply properties, and continue with our scan to BIM procedure. Another final example I want to share with you today. In this case, we have a rail station, and in the surveying business, one of the most frequently asked tasks is to find, same as the pavement, the break line along this path, along the edge. So with the same procedure, we go in, enable the profile sweep, zoom right in, trying to be as accurate as possible. And again, follow the same procedure, lower the size of this box and just define the rules of engagement. There you go. Accuracy 90, step size, let's do it 500 millimeters. And in this case, I just want the step lines. Okay, I will click on this little icon to follow the camera. The multi-steps will run across. Okay, no significant deviations so far from the accuracy point. Okay, and now it stops because clearly the accuracy fell under the 80% mark. But we can already see that the break lines have been created in a very, very precise manner. So what can we do in this case? The precision stopped, so I'm repeating the same process. I need to manually go to the next step and verify what kind of deviation we have, correct it a little bit, and then we can either do single steps, one point at a time, or just reinitiate the multi-step procedure until something goes wrong. So over here, there you go, we can undo those steps, we can go back and control the issue. Okay, so clearly after step 104, something went wrong. So in this case, I will just go ahead and remove the steps. So I can go to the last one, remove it, the current step, and so on and so forth. So we can be absolutely sure that we don't create any wrong profiles. So in this case right here, this is where the problems began. So I would recommend doing a manual step and just making sure that you have a healthy number of points, even making the depth a little bit bigger. But in this case, we can clearly see that the points are lacking. We don't have enough points to be as precise. This we can control it by using the point cloud manager on the right side. The render settings have been raised. I mean, the gap filling was included, which fills the gaps so we can make the scattered points feel like a surface. So even though this area looks nice, the reality is that we don't have nearly the amount of points required to continue this process. Okay, so what happens if we want to go in the beginning and continue towards the other side? Well, what we need to do is just click on this little button right here to invert the direction and go all the way back to step number 1. So now we completely skipped the whole path and went to the other side. So we can then continue along the other side of the path by clicking the camera icon and the multi-steps. So we continue in this way until the point cloud profile sweep completes its job. Thank you very much for your attention, and I hope you enjoy using the tool.